The Collatz conjecture, developed by Lothar Collatz in 1937, has been unsolvable for over 70 years. The 3n plus 1 conjecture, or the half or triple plus 1, is also defined by taking an even number and dividing it by 2, or taking an odd number and tripling it and adding 1. Take, for example, the number 10. 10 is even, so we do 10 over 2 equals 5. 5 is odd, so we plug it in to 3 times 5 plus 1 equals 16. 16 is even, so you take 16 and divide it by 2 and get 8. 8 is again even, and you would divide 8 by 2 and get 4. 4 is again even, so you would take 4 and divide it by 2 and get 2. 2 is again even, and you would take 2 divided by 2 equals 1. So 1 is finally odd, so you would take 3 times 1 plus 1, which is equal to 4. And let me write that down. 1 times 3 plus 1 equals 4. And we see that repeat itself. Such a property is also called oneness. If this conjecture is proven to be false, then you can plug in a number that does not give rise to a sequence that contains 1. As of now, such a number has not been found.
Today, near Vestavia Hills, Alabama, an extraordinary phenomenon is occurring that defies all explanation. The Collatz conjecture, a bizarre, purposely repeating sequence, is baffling math students everywhere. Information has been uncovered that this unsolvable math problem has been linked to several murders in the area. While no light has been shed on this repeating theory of oneness, its application has allowed local detectives to determine the perpetrator of these attacks.
It's the 4th murder in 3 weeks. We have to catch the killer before someone else gets hurt.
There's something under the body.
What is it?
A clue. So what does this mean? What do we do with these numbers?
I guess we do what we always do when you're given information. Plug in the number?
Let's try it.
Okay, so we're given this formula and the number 4, I think?
Yeah, that was what was there.
Okay, so 4 would be a 0 mod 2, so 4 over 2 equals 2.
I guess, but now what?
Oh, we have that map that we got. Let's see
Yeah.
if it's labeled anything. Let's see.
Number 2. Trenton State Asylum.
Oh, function.
This is the last room. Do you see anything?
Over there in the bathtub!
Holy shift. Oh, function. It looks like we're too late.
Who the function are you?
Stop!
Whoa. I had no function idea that body was in there.
Sure, tell it to a judge. So tell me, why did you do it?
Lothar. 1937. Half triple plus 1.
Stop!
Half triple
Stop!
plus
Never mind! No, go!
Half triple plus 1.
Are we going to arrest her?
Triple plus 1.
She's been stuck up here anyways. She couldn't have done it. The murders have been everywhere.
Well, we lost our first and only suspect. What are we going to do now?
I guess follow the next clue. So, victim number 5?
Yeah, so let's plug in 5.
Okay, so according to the formula, for odd numbers you do 3n plus 1, so n equals 5. So 3 times 5 plus 1 equals 16.
Yeah, I guess we should see where that leads to on the map.
Okay, so let's see. 16?
Looks like it.
That's Rendlesham Forest.
Derivative. It looks like someone beat us to the crime scene.
Hands up!
Hey, I just found her here! I don't know what to do. She was already dead!
I said hands up!
You're coming with us.
The ME says time of death was 2 to 3 hours ago. Where were you at 8 o'clock this morning? What? I wasn't there. I was working at the local textbook store. You can call and check. We'll be sure to do that. Well, I guess her alibi checked out.
So what do we do now? There wasn't a number with the last murder.
I guess we wait.
So much later that the old narrator got tired of waiting and they had to hire a new one.
There hasn't been another murder in a full month. The department's gonna file it away as a cold case.
I won't let that happen. Let's try plugging in those numbers we found.
Okay, so wasn't it 4 that first time?
I think so.
Okay, so 4 is even, which means we're gonna do n over 2. So 4 over 2 is 2. And then 2 over 2 is 1. Do we keep going?
Let's see if something happens.
Okay, so 3 times 1 plus 1 is 4. And then aren't we
Oh,
back here?
okay, interesting. Let's see if that's for everything. Let's try 3. I think
Yeah.
that's the next one. Okay, so 3 was odd, so that means you do 3 times 3 plus 1 equals 10. And then 10's even, so 10 over 2 equals 5, another odd number, so 3 times 5 plus 1 equals 16. Even, so 16 over 2 equals 8. 8 over 2, oh, I think this may be starting again. So I guess 4 goes back to 1 again?
I mean, I guess so.
Okay, let's pick another random number. Yeah.
Let's try 6.
Okay.
So 6 is even. So 6 over 2 is 3. And 3 is odd. So 3 times 3 plus 1 gives us
Oh,
10.
that's very similar to this.
I guess keep going.
Oh.
10 over 2 gives you 5.
Okay, so I guess it follows the same pattern. 5, 6, and 8, 4, 2, 1. Wait, let's write that out. Okay, so starts with 1, and then you get 4, and then 2, and then 1, and then 4, 2, 1.
Yeah, I mean, I guess so. It looks like it always comes back to 1.
Wonder why that happens.
I don't know. Because the Collatz conjecture is made up of 2 linear sequences with an infinite number of positive integers that we can put in, we don't know if the last 4 digits are always going to be this, because there are an infinite number of positive integers that you can put in.
This is weird. Let's check number 1 on the map.
Oh, it's...
My house. I'm the one.
Oh,
Okay.
Are we just gonna jog?
Wait,
Go.
Are we